Dear students, today we are going to discuss about one problem in matrices. The problem is find the eigenvalues and eigenvectors of the matrix 2, 1, 0, 0, 2, 1, 0, 0, 2. Let us start the solution. Let A is equal to 2, 1, 0, 0, 2, 1, 0, 0, 2. We have to consider the given matrix by A. So what are the procedures for finding the eigenvalues and eigenvectors? Our step 1 is nothing but to find the characteristic equation. But in this problem, directly I found the characteristic roots because here we are having an upper triangular matrix. We are having one property of eigenvalues. Suppose we are having an upper triangular matrix, the main diagonal elements are the eigenvalues of A. The main diagonal elements are the eigenvalues of A. That's why not necessary to find the characteristic equation. Whether you are having an upper triangular or a lower triangular matrix, the main diagonal elements are the eigenvalues of A. Therefore, step 1 is nothing but to find the characteristic roots. Here the given matrix is an upper triangular matrix. Therefore, by property of eigenvalues, the main diagonal elements are the eigenvalues of A. Therefore, the eigenvalues are lambda equal to 2, 2, 2 because the main diagonal elements are 2, 2, 2. And our step 2 is nothing but as usual to find the eigenvectors. The formula for finding the eigenvector is nothing but A minus lambda I into x equivalent to 0. At the time in a given matrix A, we have to subtract lambda from the main diagonal elements. Therefore, 2 minus lambda 1, 0, 0, 2 minus lambda 1, 0, 0, 2 minus lambda. That is A minus lambda I. That is in a matrix format. And x is nothing but a non-zero column vector x1, x2, x3 equivalent to, for our convenient, 0 can be written as 0, 0, 0 column vector. Call it as equation 1. When lambda is equal to 2, equation 1 becomes matrix is nothing but 0, 1, 0 because in our main diagonal elements are 2 minus lambda, 2 minus lambda, 2 minus lambda. That's why you have to subtract the 2 from the main diagonals. At the time 0, 1, 0, 0, 0, 1, 0, 0, 0. That is our matrix now. And the non-zero column vector is x1, x2, x3 that is equal to 0, 0, 0. That is, we are having 3 equations with 3 unknowns. Last equation is nothing but 0. We don't bother. So, first equation can be written as 0x1 plus x2 plus 0x3 equivalent to 0. Call it as equation 1. 0x1 plus 0x2 plus x3 equivalent to 0. Call it as equation 2. 0x1 plus 0x2 plus 0x3 equivalent to 0. Call it as equation 3. So, first 2 equations are distinct. Solve the equation 1 and 2. So, distinct equation we are having. That's by using rule of cross multiplication. Therefore, x1 by 1 minus 0 equivalent to x2 by 0 minus 0 equivalent to x3 by 0 minus 0. Therefore, the value of x1 is nothing but 1, x2 is nothing but 0 and x3 is nothing but 0. Hence, the corresponding eigenvector is x is equivalent to 1, 0, 0. Here we are having only one eigenvector because we are having 3 equations with 3 unknowns. At that time, we got 3 distinct equations. That's why only one possibility we are having, that is rule of cross multiplication. You have to choose any 2 distinct equations. After that, using rule of cross multiplication. That's why here we are having only one eigenvector. That is x is equivalent to 1, 0, 0. That is a column vector, non-zero column vector. Thank you.